In this video, we discuss definite integral chapter. This is totally depending on indefinite integration. If you are thorough in indefinite integration, definite integrals is very easy. Just limits are there in definite integrals. In this chapter, we discuss 5 points mainly in this part 1. That is first one, fundamental theorem of integral calculus. Second one, that is geometrical interpretation. Third one, algebraic properties. Fourth one, substitution method. Fifth one, integration by parts. Now we are going to the first one, fundamental theorem of integral calculus. That is, let f be a integrable function on closed interval a. Let f be integrable on closed interval a b. If there exists a differentiable function capital F of x such that f dash x equal to small f of x, then integral a to b small f of x dx equal to capital F of b minus capital F of a. This is called fundamental theorem of integral calculus. Now here, capital F dash x is small f of x. That means f of x, small f of x integration is capital F of x plus c. So look here, simply we can prove that a to b f of x dx that equal to integral a to b f dash x dx. F dash x integration is capital F of x plus c over the limits a to b. Here just you have to substitute upper limit in this function. That means f of b plus a plus c minus f of a plus c. So here c cancel, the same constant carrying. So both are constant, cancel. We get f of b minus f of a. So here integral a to b f of x dx is a unique value, f of b minus f of a. That is a unique value. Whereas in indefinite integration, integral small f of x is capital F of x plus c. That is a family of curves. If c varies, we get different curves. Whereas in definite integral, it is a definite value, it is a fixed value, it is a unique value, f of b minus f of a. Integral a to b f of x dx is. This is called fundamental theorem of integral calculus. Just we have to integrate that function. After that, in that function, substitute upper limit b minus lower limit a. In this definite integral, we need not write the constant c. If you write, that cancel. So we need not write the constant. So now we are going to the geometrical interpretation that we discuss. Here f of x be a, let f of x be a continuous function on closed interval a b, and f of x greater than or equal to 0. Second point, geometrical interpretation. F of x be a continuous on closed interval a b, and f of x greater than or equal to 0. Then integral a to b f of x dx, that is nothing but the area of the region bounded by y equal to f of x, bounded by the curve y equal to f of x, and the lines x equal to a, x equal to b with x-axis. That means it is the area of the region. These are the boundaries. One boundary is y equal to f of x. Y equal to f of x. It is the curve y equal to f of x. It is the line x equal to a, vertical line. It is the line x equal to b, vertical line. With x-axis. Look here, the region contains four boundaries. One is y equal to f of x, and two are vertical lines, and another one horizontal line, that is x-axis. So the region, the shaded region, this area is area of the region bounded by these four. The area is nothing but the integral a to b f of x dx. This value is that. For example, if you take integral 0 to pi sin x dx, you know sin x dx, that integration is, sin x integration is minus cos x over the limits 0 to pi. You substitute the limits, minus take out cos pi minus cos 0, cos pi is minus 1, minus cos 0 is 1, so that is 2. So the two square units, that is the area of the region bounded by the curve y equal to sin x from 0 to pi, x equal to 0, that is y axis here. Next, x equal to pi, this line x equal to pi, this is x equal to 0, it is y equal to sin x, that is one curve, it is x-axis is one boundary. So this is nothing but 2 points. So the area of the curve with x-axis is 2 square units. Actually, we don't have any formula, standard formula, but we have, if you want the area of this region bounded by this curve, we can easily calculate by using the definite integral concept. By using this concept directly we can get that. So this area is 2 square units, integral 0 to pi sin x dx. Here f of x is greater than or equal to 0. Here sin x is also greater than or equal to 0. That means that is above the x-axis. If it is down the x-axis, if some part is above the x-axis and below the x-axis, how to find the area, that we discuss in the another chapter, areas. Especially we discuss the areas bounded by the curves and the lines, different types of lines. There we discuss. Okay. Now we are coming to the algebraic properties of definite integrals. That is next one. Integral a to b f of x dx. If we interchange the limits, what happened? If we break the interval, what happened? That we discuss here. Now, algebraic properties. Third one. Integral a to b f of x dx, that equal to, if we interchange the limits, that value is minus integral b to a f of x dx. As well as second one, if the limits are equal, a to a only, in that case that value is 0. If we break the limit, that means integral a to b f of x dx, we can break that equal to integral a to c f of x dx plus integral c to b f of x dx. We can break that. C belongs to open interval AB, lie between any number. So we can break this interval not only in 2 subintervals, we can divide into 3 subintervals, 4 subintervals, 5 subintervals, like that. A to C1, C1 to C2, C2 to C3, C3 to B. Like that we can break that interval. Now, fourth one, next point. If f and g are 2 integrable functions, integral a to b f plus or minus g of x dx, we can separate that a to b f of x dx plus or minus integral a to b g of x dx. If there is a constant, for example, integral a to b k f of x dx, k is constant, so we can write that k before the integral a to b f of x dx. We can separate that constant k. These are the algebraic properties. But here plus or minus we can split it. If there is product or division, we can't split it. We can't split it. That way, learn in indefinite integration, previous chapter. Now, substitution method. Substitution method. Integral. Substitution method. That is fourth one. Integral a to b f of g of x into g dash x dx. If the function is like that, the composite function, just we have to substitute t equal to g of x. Substitute t equal to g of x implies dt by dx equal to g dash x implies dt equal to g dash x dx. Here t equal to g of x and g dash x into dx, that is dt. That is dt. G of x is t. Now how to, whenever you change the variable, automatically these values also change. X varies from a to b. T equal to g of x. So t varies from g of a to g of b. Therefore, the given integral that taken as I equal to integral a means it is I. It is nothing but I. I equal to a varies from, these are a and b are the x limits. Now we have to find the t limits. According to the x limits, x varies from a to b, t varies from g of a to b, g of b, because t equal to g of x, that's why g of a to g of b. Integral g of a to g of b, that is f of t, g of x is t into g dash x into dx, that is dt. So, whenever you substitute x equal to something, immediately you have to change the limits of x according to the new variable. According to the new variable, then we get the same value. We need not substitute, we get the integration, we need not substitute t in terms of x. Don't change t in terms of x. Directly substitute the values, then we get that. For example, integral for example, substitution method. Integral 0 to pi by 4 sin x plus cos x by 9 plus 16 sin 2x dx. Now here we are substituting t equal to sin x minus cos x. How to know why you are substituting particularly this? Just simple. If you differentiate this dt by dx, that means that is sin x derivative is cos x derivative is minus sin x, minus is there, so plus sin x, which implies by cross multiplication sin x plus cos x dx, cos x plus sin x dx is dt. That part is there, sin x plus cos x is there, dx is there. That's why we are substituting t equal to sin x minus cos x. Now t square equal to, which implies t square equal to, whenever you squaring sin square x plus cos square x, that is 1, minus 2 sin x cos x, that is sin 2x. So 1 minus sin 2x. So sin 2x is 1 minus t square. Sin 2x is 1 minus t square, as well as cos x plus sin x dx is, that part is dt. These two we have to substitute here. Now x varies from 0 to pi by 4 implies t varies from sin 0, 0, cos 0, 1. So this value is, whenever you substitute x equal to 0 in this, we get minus 1. Minus 1 to 0. Minus 1 to 0. T limits are minus 1 to 0. T varies from minus 1 to 0. Therefore, the given integral, let it be I. Therefore, I taken as, we have to immediately convert the limits as t limits. They are minus 1 to 0. Sin x plus cos x dx is dt, whole divided by 9 plus 16 into 1 minus t square. That equal to integral minus 1 to 0. 9 plus 16, 25 minus 16 t square. So dt by 25 minus 16 t square. Okay, that is of the form 1 by a square minus x square. That integration is 1 by 2a log mod a plus x by a minus x. Here a means 5, b x means that is 4t. So that equal to 4t is there, 4t whole square. So you have to write down 1 by 4. After that the formula 1 by 2a log mod 5 plus 4t by 5 minus 4t modulus over the limits minus 1 to 0. Now you substitute 0, we get log 1. Log 1 is 0, 1 by, this value is equal to 1 by 40 into log mod. If you substitute 0, that becomes log 1. Log 1 is 0 minus, substitute t equal to minus 1. 5 minus 4, 1. 1 by 9, log 1 by 9. Log 1 by 9 is 3 power minus log 1 by 9. That means 3 power minus 2. Minus 2 take before. 2 log 3 plus 2 log 3. 2 cancel. So totally this value is equal to 1 by 20 log 3. This value is here. My dear students, you have to observe here. Whereas in indefinite integration, final answer we have to convert in terms of x. Finally, we have to substitute t as sin x minus cos x. But here in definite integral, we need not go back the previous variable, old variable x. We are changing the limits of t. X limits are given 0 to pi by 4, but we change the limits according to the new variable t. The limits are minus 1 to 0. You have to substitute these values. Finally we get that. Okay, this is the unique value. Don't write C, not necessary. Okay, next concept, that is integration by parts. Integration by parts. Now we discuss the fifth concept in this part, that is integration by parts, that we learn in indefinite integrals. If f of x and g of x are two integrable functions from closed interval a b, then integral a to b f of x gx dx, that equal to fx integral gx dx over the limits a to b minus integral a to b f dash x integral gx dx whole dx. Integration by parts. Here we are not applying the limits. Here we need not, don't write here a to b. First you have to find g of x integration. After that the product of f of x and g of x. To that product apply the limits a to b. Next, minus integral a to b, derivative of first function, integration of second function dx. That we learn which one is first, which one is second. That we learn in indefinite integral by using the word eyelet. According to the eyelet, we can choose fx, which one is fx and which one is gx. Now we are going to one example, that is integral 0 to pi by 2, 0 to pi by 2 x square sin x dx. Integration by parts. Which one is fx? Which one is gx? X square is algebraic function. Sin x is trigonometric function. A is first. A is before t in islet. ILATE. A is before t islet. So it is f and it is g. Now apply the formula, integration by parts. Fx integral gx sin x integration is minus cos x over the limits 0 to pi by 2 minus integral 0 to pi by 2 f dash x square integration, that is 2x, integral sin x, that is minus cos x dx. Now apply the limits. Upper limit first. How to apply? Substitute x equal to pi by 2, upper limit. Cos pi by 2 is 0. So entire product is 0. Minus x equal to 0. So product is 0. Take out minus plus. To take out 2 integral 0 to pi by 2 x cos x. Again use the integration by parts. In that fx is x and gx is cos x. Now 2 into fx integral gx cos x integration is sin x over the limits 0 to pi by 2 minus integral 0 to pi by 2 f dash x 1 cos x integration sin x dx. Now apply the limits, that equal to 2 into x pi by 2, sin pi by 2 is 1, so pi by 2 minus lower limit 0, 0. Here minus sin x integration is minus cos x, already minus is there, so plus cos x over the limits 0 to pi by 2, 0 to pi by 2. So that equal to 2 into pi by 2 is pi plus cos x cos pi by 2 0 minus 1 cos pi by 2 0 minus 1. That means 2 is there. Look here. Actually here 2 into pi by 2. Okay. Now multiply with 2. That equal to pi minus 2. So that value is integral 0 to pi by 2 x square sin x dx, value is pi minus 2. We are using here integration by parts 2 times. Now we get the final answer. Now, so my dear students, it is part 1 definite integrals. In definite integrals nearly 5-6 parts are there. We discuss all the concepts in definite integral. So observe the video, subscribe my channel. Thank you.